Somewhere in the desert south of Cairo, inside a museum case that most tourists walk straight past, sits a box of solid granite. It has flat sides, it has sharp 90-degree corners. Its interior has been hollowed out so precisely that engineers who have measured it with modern tools say the tolerances rival what you would expect from a machine shop today. Not a civilization that supposedly hadn't even discovered iron. Stand close enough, and you can still see the marks left behind by whatever cut it. Thin parallel lines. Spiral grooves inside drilled holes that look, to more than one modern machinist, exactly like the kind of groove a high-speed power tool leaves behind. And that single observation, repeated across dozens of artifacts scattered from Giza to Aswan to the Cairo Museum, is the seed of one of the most persistent and most argued about ideas in all of alternative history. Graham Hancock's claim, stated bluntly, is this: we've been wrong about how the Egyptians cut granite. Not a little wrong, fundamentally wrong. Wrong in a way that, if true, would force us to rewrite the story of human civilization itself. Before we go further, it's worth being honest about what this video actually is. It is not a verdict. It is an investigation into a genuine, ongoing argument, one being fought right now between career Egyptologists, professional machinists, geologists, and a very persuasive British journalist who has spent 4 decades making the case that ancient history has a missing chapter. We're going to walk through both sides of this fully, the evidence Hancock and his allies point to, and the evidence mainstream archaeology uses to push back, so that by the end you can weigh it for yourself. Because whatever you conclude, the granite itself isn't lying. Something cut it. The only question is what, and how, and who. Let's start with the stone itself, because you cannot understand why this argument even exists until you understand what granite actually is. Granite is what geologists call an igneous rock, formed from magma that cooled slowly deep underground, which gives it a coarse crystalline structure built mostly from 3 minerals: quartz, feldspar, and mica. The one that matters here is quartz. On the Mohs hardness scale, a rough measure of how easily a material scratches or gets scratched, quartz sits at about a 7. Copper, the primary metal available to the Egyptians for most of the Old Kingdom, sits at about 3. That gap matters enormously. In practical terms, it means a copper chisel or copper saw on its own cannot cut granite. It would simply deform, bend, and wear away long before it made a dent in the stone. Bronze, which arrived a little later and is harder than pure copper, still falls well short of quartz on that scale. Iron tools, which could plausibly do the job, don't show up in Egypt in any real quantity until roughly 1,000 years after the pyramids were built. So right from the outset, there's a real measurable physical puzzle sitting at the center of Egyptian granite work. The tools we know they had should not have been capable of doing what we can see with our own eyes that they did. This isn't a fringe observation. It's the starting point for mainstream Egyptology too. Where the two camps split is over what happens next. The traditional textbook answer, the one that's been taught in universities for over a century, goes like this. The Egyptians never actually cut granite with copper alone. They cut it with copper plus an abrasive, and the abrasive did the real work. Picture a copper saw blade, thin and soft, dragged back and forth across the surface of a granite block with sand poured into the groove. The sand, which is largely made of tiny quartz crystals, is just as hard as the quartz inside the granite itself. The copper blade isn't the cutting edge at all. It's really just a carrier, a delivery mechanism that holds the abrasive grains in place and drags them across the stone under pressure. Over time, with enough passes, enough sand, enough patience, and enough manpower, a groove appears, then deepens, then eventually slices all the way through. The same logic applies to drilling. Instead of a solid drill bit, the Egyptians are believed to have used a hollow copper tube, again fed with sand and probably water, rotated by a bow drill or worked by hand, grinding its way down into the stone and leaving behind a cylindrical plug, a drill core in the center. Pull that plug out, and you're left with a neat round hole. This isn't just theory. It's been tested. Archaeologists and experimental researchers, going back to the early 20th century with Flinders Petrie and continuing through more recent work by specialists like Dennis Stocks, have actually built replica copper saws and copper tube drills, fed them quartz sand, and used them on real granite. And it works. It's slow. It's laborious. It would have required an enormous amount of organized labor, replacement tools, and time. But it functions. Grooves appear. Holes get drilled. Flat surfaces can be produced. Stocks, in particular, spent years recreating ancient Egyptian tools, using only materials and techniques that would have been available at the time. And he was able to reproduce cut marks in granite that closely resemble the ones found on actual artifacts. To the mainstream view, this closes the case. No lost technology is required. Sand, copper, water, time, and thousands of organized workers get you there. There's more supporting evidence too, and it's physical, not theoretical. At the ancient granite quarries near Aswan, which is where the vast majority of Egypt's granite for royal monuments actually came from, archaeologists have found the leftover tools in bulk. Not a handful, thousands of them. Hard, rounded stones made of dolerite, a dense igneous rock even tougher than granite itself, worn smooth on one side from repeated pounding. These dolerite pounders appear to have been used almost like hammers, pounded directly against the granite bedrock over and over to slowly crush and wear channels into it, isolating a block from the surrounding stone before it was ever touched by a saw or drill. The most famous piece of evidence at Aswan is the so-called unfinished obelisk, a colossal shaft of granite still attached to the bedrock, abandoned partway through quarrying, apparently because a crack appeared in the stone. Walk around it today and you can see the pounding channels running along its sides, wide enough for workers to have crouched in and swung their dolerite hammers by hand. To Egyptologists, this is about as close to a smoking gun as archaeology gets. It's not a depiction of the process. It's the process itself, frozen halfway through in the open air, for anyone to inspect. So that's the mainstream case, and it's a genuinely strong one. Now here's where Graham Hancock and researchers like machinist and engineer Christopher Dunn start pushing back hard. Their argument isn't that copper and sand couldn't cut granite at all. It's that copper and sand cannot explain the specific character of what survives. And they point to details that, they argue, the sand and dolerite explanation glosses over or simply can't account for. The first is precision, not just flatness, but a level of flatness and symmetry that, when measured with modern instruments, is startling. Christopher Dunn, who spent his career as a machinist and toolmaker before turning to Egyptology, has described running precision measuring tools, straight edges and optical flats of the kind used in modern manufacturing, across the surfaces of granite boxes and sarcophagi in Egypt. In more than one case, he reports finding no detectable deviation from a true flat plane, the kind of tolerance that, in his professional life, he associated with machined surface plates, not hand tools. He's made similar claims about statues, describing facial symmetry on certain Ramses II statues that, when analyzed with computer-aided design software, come back as close to mirror images, left side to right side, in a way he argues is exceptionally difficult to achieve by eye and by hand. The second detail is the drill cores, and this is probably the single most cited piece of evidence in the entire debate. When the Egyptians drilled into granite with a tubular drill, they left behind cylindrical cores, essentially the stone equivalent of the little plug you get when you use a hole saw on wood. A number of these cores survive, some in the Petrie Museum in London, and on their surfaces you can see spiral grooves cut into the granite in a smooth, continuous helical pattern. Petrie himself, back in the early 1900s, examined these and speculated that the spacing and consistency of the spirals implied a very rapid rate of cutting faster, he suggested, than he thought hand-powered rotation with loose sand should be able to achieve. Dunn picked this thread up decades later and pushed it further, arguing that the spiral pattern and its consistency look less like the somewhat irregular scratching you'd expect from a soft copper tube dragging loose grit around, and more like the even helical feed line left by a fixed, hard-cutting point spinning at speed, something closer to how a modern lathe or power drill leaves its mark. From there, the claims escalate. Dunn has gone further still, proposing in his writing that certain artifacts show evidence not just of high-speed rotation, but of what he describes as an almost machined quality, hinting in his more speculative work at forms of vibrational or ultrasonic-assisted cutting, the idea being that a tool vibrating at very high frequency could exploit the natural resonant properties of quartz crystals within the granite, essentially inducing the stone to assist in its own destruction. Hancock, for his part, tends to frame this a little differently and somewhat more cautiously than Dunn does. Rather than insisting on a specific mechanism like ultrasonics, Hancock's broader argument is that these anomalies, taken together, are consistent with the fingerprints of a lost, technologically sophisticated civilization that predates dynastic Egypt, one that may have reached a level of technical capability he's compared loosely to something like 19th century industrial society, and which was largely wiped out by a global cataclysm at the end of the last ice age, something in the neighborhood of 12,000 years ago. In his view, the Egyptians we know from the history books weren't the ones who first solved the granite problem. They were inheritors, working with knowledge and possibly even a few surviving tools or techniques passed down from a civilization that came before them and largely vanished. It's a big claim, and it's worth pausing to notice how big. This isn't simply saying the Egyptians were cleverer than we give them credit for. It's saying that an entire advanced civilization existed, thrived, and was erased so thoroughly that essentially no direct archaeological trace of it remains, aside from these scattered, disputed clues in the stonework of a much later culture. That's the part where most professional archaeologists get off the train, and it's worth walking through exactly why. The first and most basic objection is the absence of any independent evidence for this lost civilization. Archaeology, as a field, doesn't just look at finished products and ask how impressive they are. It looks for the full ecosystem of evidence a technological society leaves behind. Settlements, tools in every stage of manufacture and wear, waste material, burial practices, written records, art depicting daily life and industry, evolving styles over time that show a culture developing its skills gradually rather than appearing with them fully formed. In dynastic Egypt, all of that exists in overwhelming abundance. We have workers' villages at Giza, complete with bakeries, breweries, medical evidence of the physical toll the labor took on skeletons, administrative records tracking food rations for work crews and quarry marks, literally graffiti left by ancient work gangs bragging about which team cut which stone. We can trace the evolution of Egyptian stoneworking skill across centuries, watching it improve incrementally from the earlier 3rd Dynasty through the sophistication of the 4th Dynasty pyramid builders. For Hancock's lost civilization, none of that exists. No settlements, no tool workshops, no gradual technological record, no written language. Just, allegedly, a handful of especially precise artifacts embedded within a culture we otherwise understand quite well, and no independent trace of the people who supposedly made the more advanced version. Mainstream researchers argue that a civilization capable of what Dunn describes, precision machining, high-speed rotational tools, possibly even electricity or vibrational power sources, would leave behind an enormous footprint of its own. Tool marks in a huge range of contexts, industrial waste, evidence of mining and metallurgy on a much larger scale, and that the total absence of any of that is not a minor gap. It's close to disqualifying. The second objection goes directly at the precision claims themselves, and it's a more technical argument, but an important one. Critics point out that when you take modern optical measuring instruments to ancient artifacts, you will often find surprisingly tight tolerances. Not because the object was machined by advanced technology, but because skilled human hands, working slowly, checking their work constantly against a straight edge and correcting small errors over the course of what might have been weeks per surface, can achieve extraordinary results. Human craftsmanship, especially unhurried, methodical, repetitive craftsmanship, performed by workers with nothing but time and generations of accumulated technique, tends to be underestimated by people encountering it for the first time through a modern industrial lens. A flat surface produced by a skilled mason rubbing 2 stones against each other with abrasive grit between them for days, checking periodically with a straight edge and correcting high spots, can end up extremely flat. Not because a machine did it, but because that's what patient, repeated correction produces. The same argument applies to facial symmetry on statues. Egyptian artists worked from grid systems, canon proportions passed down through training that governed exactly how a face, a body, and its features should be laid out before carving even began. Symmetry that looks uncanny to a modern eye may simply be the product of a well-understood, carefully applied artistic formula, refined over centuries, rather than evidence of a laser scanner. The third objection concerns the spiral grooves on the drill cores, and this is where the argument gets genuinely into the weeds, but it matters. Skeptical researchers and experimental archaeologists have gone back to Petrie's original drill core observations and pointed out something Petrie himself never actually claimed with certainty, that the spiral pattern requires rapid rotation. Later experimenters, including teams that have built and used replica copper tube drills fed with loose quartz sand and crushed stone, have managed to reproduce very similar spiral grooving on granite at speeds entirely consistent with a hand or bow-operated drill, no motorized rotation required. The physics, they argue, actually works in the Egyptians' favor here. As a rotating tube grinds down through stone using an abrasive slurry, individual grains of sand and quartz get trapped and dragged along the advancing edge of the tube in a way that naturally tends to produce a helical scratch pattern, simply as a geometric consequence of how the abrasive particles move relative to the rotating cutting surface. In other words, the spiral isn't necessarily evidence of speed at all. It may just be what any rotating tube abrasive drilling process looks like, whether it's turned by hand in 2500 BC or by an electric motor today. There's also a quieter, more mundane point that tends to get lost in the more dramatic framing of this debate, and it concerns time and manpower. When you're arguing that a technique like sand abrasion is too slow or too primitive to have plausibly produced these results, you're making an assumption about how much time and labor the Egyptians were willing to spend. But everything else we know about how the pyramids and their associated monuments were built points to a civilization that had, essentially, an almost unimaginable surplus of organized human labor and state-level patience, multi-generational building projects, tens of thousands of workers on rotating rosters, a centralized administrative system capable of feeding, housing, and directing that labor for decades at a stretch. In that context, a technique that might sound impossibly slow to a modern viewer, cutting a groove into granite 1 sand grain at a time, stops sounding so implausible. It's not fast. It was never meant to be fast. It was meant to be reliable, repeatable, and achievable with the materials on hand over as many years as it took. So where does that leave us? It leaves us, honestly, in a genuinely contested space, which is rarer in archaeology than television often makes it seem. On one side, you have a well-documented, experimentally tested, physically corroborated technique, copper tools, plus quartz sand, plus dolerite pounding, that fits within the broader, richly evidenced picture of dynastic Egyptian society, its labor systems, its tool workshops, its recorded administrative structures, and its gradual traceable development of skill over centuries. On the other side, you have a set of genuinely striking, sometimes hard to dismiss visual and measurable anomalies, unusually flat surfaces, unusually symmetrical carvings, spiral drill cores that some experienced machinists find hard to intuitively square with hand tools, interpreted by Hancock, Dunn, and others as evidence of either a technologically superior lost civilization or, at minimum, of techniques more sophisticated than the accepted textbook explanation currently allows for. It's also worth being honest about something that rarely gets said clearly enough in either direction. Mainstream Egyptology is not a monolith that has closed the book and stopped looking. Experimental archaeology, the actual physical process of trying to replicate ancient techniques with ancient materials, still an active, evolving field, and researchers continue to refine exactly how these tools might have been used, in what sequence, with what level of efficiency. It's entirely possible, even likely, that our full understanding of Egyptian stoneworking isn't finished, that there are still details about tool design, technique, or organization we haven't fully reconstructed. That's simply how archaeology works. It updates. But updating the details of a well-evidenced technique is a fundamentally different thing than the claim Hancock is making, which requires not a refinement of the existing story, but its replacement with an entirely separate, otherwise undocumented civilization, for which no independent evidence has ever surfaced, despite well over a century of intensive excavation across Egypt. What makes this particular corner of the ancient history debate so durable, so endlessly recirculated across YouTube and social media and new packaging every few months, is that it sits right at the intersection of something real and something speculative. The real part is the stone itself. Granite is objectively, measurably hard. The tool marks on these artifacts are objectively, measurably present, and in some cases genuinely difficult to casually explain. That's not manufactured mystery. Egyptologists themselves have spent decades studying exactly these puzzles, publishing papers, running experiments, arguing among themselves about the finer points of Petrie versus Lucas versus later researchers like Stocks. The speculative part is the leap from those unresolved technical details straight to a vanished global civilization with technology comparable to the industrial age, a leap that requires you to set aside the complete absence of corroborating evidence for that civilization anywhere else in the archaeological record. Where you land on this probably depends on how you weigh two different kinds of uncertainty. If you're the kind of person who finds it hard to accept that any unresolved technical detail exists without a dramatic explanation, the spiral grooves and the flawless flat surfaces will likely read as proof of something hidden. If you're the kind of person who defaults to the explanation requiring the fewest additional assumptions, the sand, the copper, the dolerite pounders, the millions of accumulated labor hours, all of it sitting comfortably within a civilization we already know built the pyramids, will probably feel like the more solid ground to stand on. Neither position, honestly, requires you to think the ancient Egyptians were unimpressive. Quite the opposite. Whether you side with Hancock or with the archaeological mainstream, the granite itself forces the same conclusion either way. Somebody, working with knowledge, patience, and organization that we are still working to fully understand, looked at one of the hardest stones on the planet and decided it would bend to their will. The debate isn't really about whether that's remarkable. Everyone agrees it's remarkable. The debate is only about who deserves the credit and whether the full story has already been told, or whether, buried somewhere under the sand, there's still a chapter nobody has found yet. That question, more than any single spiral groove or flat granite surface, is probably why this argument refuses to die. It isn't really about ancient Egypt at all, not entirely. It's about whether we believe the story of human capability that we've already pieced together is complete, or whether there's still room, somewhere in the deep past, for a surprise big enough to rewrite it. Graham Hancock has built an entire career betting that there is. Mainstream archaeology has built an entire discipline on the position that extraordinary claims require extraordinary evidence, and that so far, for this particular puzzle, that evidence hasn't shown up. Both sides are looking at the exact same stone. They just can't agree on what it's trying to tell us. And until someone finds something more concrete than another measurement or another drill core, that's likely to stay exactly where it is, unresolved, contested, and endlessly compelling, which might be the real reason this story keeps coming back around every few months, on this channel and every other one, covering the mysteries the ancient world still hasn't fully given up.